Everyone, here we have a question of chapter alternating current. We are given a circuit which shows AC source with a voltage of V is equals to 200 sine omega t and connected to a 100 ohm resistor. Okay, we have to find RMS voltage, RMS current, and average power delivered to the circuit. Okay, so for the first question, okay, how do we find the RMS voltage? So we have the formula of RMS voltage. Number one, V RMS, which is equals to V naught over Z2. So how do we find the V naught? So V naught is coming from this equation. So we compare this equation with our general equation, which is V is equals to V naught sine omega t. So here we get V naught is equals to 200. Okay, so just put the value of V naught 200 divided by Z2 and we can get 141.4 volt. Okay, for number 2, we have to find the value of RMS current. So for RMS current, IRMS, we have to find the I naught, where we will divide it by Z2. So how do we find I naught? So I naught we can get from the equation of V naught is equals to I naught R. So we have the value of V naught, which is 200, and we have the value of resistance, which is 100 ohm. Okay, now we can get the I naught is equals to 2 ampere. So put the value of I naught 2 ampere divided by Z2 and we will get the value of I naught IRMS is equals to 1.41 ampere. The third question, we are going to find the average power delivered to the circuit, which is P average is equals to IRMS square times with R. Okay, so IRMS is equals to 1.41 square times with 100 ohm, so we can get 198.8 watt. Okay, now we are going to check on second question. Okay, for the second question, we have a series of RLC circuit consisting of 35 millihenry of inductor, 45 microfarad of capacitor, and 85 ohm resistor. So all of these devices are connected to a generator, AC generator with 150 volt and 60 hertz. So for the first question, we have to find the capacitive reactance. So for capacitive reactance, we are going to use the equation of Xc is equals to 1 over 2 pi Fc. Okay, the 1 over 2 pi, okay, our F is equals to 60 hertz times with our C capacitor is 45 micro. So 45 exponent negative 6. So the Xc or the capacitive reactance is equals to 59 ohm. Okay, now for the second question, we have to find inductive reactance. So for inductive reactance, we are going to use the equation of XL is equals to 2 pi FL. 2 pi, put in the value, so 2 pi times 60 Hertz times with our inductor 35 millihenry. So 35, so milli is negative 3. Okay, then we can get the answer is 13 ohm. For the third one, we are going to find the impedance. So for impedance, the equation is equals to Z is equals to surd of R square plus XL minus XC square. So R is equals to 85 ohm plus XL is equals to 13 minus with XC is equals to 59, and then we square and we set this equation. Okay, now we can get the value of this Z is equals to 97 ohm. Okay, for the last question, we are going to find the phase angle with the symbol of phi. Okay, here phi we can use cos or tangent from the phasor diagram. Okay, we can get the value of phi from phasor diagram, which is phi is equals to inverse tangent of XL minus XC divided by R. So our XL is equals to 13 minus 59 divided by 85. Okay, so lastly we can get the value of phase angle of negative 28.4 degree. Okay, good luck.